Thank you.
I'll be calling on our next speaker, Mauricio Vinasco. You there?
Hello, you hear me?
Oh, hello. How are you, Mauricio?
Hello, Hassan, and Cara, and Rosa, everybody.
Yeah, so Mauricio, the title of his talk is Project CLEA after 22 years. It's a pre-recorded talk. And our colleague, Gustavo, do you have the video or you want to share it, Mauricio? Gustavo? Yeah, so Gustavo is sharing the talk.
Hello, this is Mauricio Vinasco. I want to talk to you about Project CLEA after 22 years. I want to share with all of you my experience as a teacher in astronomy, because a decade ago, for near 15 years, I began to use CLEA software. It was an amazing discovery, because since then I enjoy using it with my students. So if you want to contact me for any questions, this is my email. Anyway, also you can contact people at Department of Physics of Gettysburg that work with video, the Virtual Education Observatory. So I want to thank Lawrence Marshall for authorizing me to talk about video. Video, I repeat, it means virtual observatory exercise, and video is the result of a project from CLEA, that means Contemporary Laboratory Exercises in Astronomy, also with the support of the National Science Foundations and NASA. Video is not supported anymore, but if you want, you can download the software and a very good manual. And sorry, unfortunately, video doesn't work for Mac or Linux operating systems. So now just Google CLEA video. You're gonna see this web page. Here you can download, and also you can of course contact people charged of video. So here is the principal file called video.zip, and two manuals in different formats. But video have 7 exercises, just 7, and if you want to download other exercises, you can look for them in another page. So this is video software. Initially we click on File, Login, then students fill here and the information here, and we can skip this step. Then we run the exercise we want to. Let's see first photoelectric photometry of the Pleiades. Here we're gonna practice some concepts as magnitude in order to find the distance to the Pleiades cluster. So we have to request time in a telescope. Let's request in a 0.meter telescope. Okay, here we are inside the dome. So let's open it. Okay, something fell down. No problem, let's continue. Here we take control of the telescope, and we can see some interesting information. For example, universal time, side sidereal time, right accession and declination of the point the telescope is pointing to. Then we track the position. We slew to one of the 24 stars of the Pleiades clusters. Of course, my students have to take data of all 24 stars. Okay, now we flew to this star. Now we change the option to telescope, and here it is, one of the stars of a Pleiades cluster. Now we access to the photometer, and we have this on our interface where we can change the filter and take to 1 to 5 integrations, each integration from 0.1 second to 100 seconds. And let's see an example. Here I change to the sky. I move the telescope one side of the star and take data and photon count. Now I point again to the star. I change this option. This is the name of the star, and I take the data. Finally, I can see its magnitude, and I save this information. Now the idea is try to deduce the absolute magnitude of this star with many data in a main sequence graph we construct, and compare it with a main sequence graph with absolute magnitudes. Then we can, so we deduced the absolute magnitude of this star. This is the apparent magnitude, and with those data we can deduce the distance to this star. We repeat the same procedure with all 24 stars, and finally we take the mean of this distance. This is the objective, and as you can see, we practice the photometry technique. Let's see another example. So again, students fill this information, and we choose another exercise. Let's see an exercise to practice the spectroscopy. This one, classification of stellar spectra. The idea is to deduce what kind of star is one of the stars we're gonna point. Again, we choose we request time is in a 0.1 meter telescope. We open again, something fell down or broke. Now we change to the control panel. Here we can choose a star, and we move the reticle to the star. Then we access the spectrometer, and we can change this range from 3700 to 7000, or we can just take the spectra from 3700 to 4700. Now, mm, quickly, because it was a very bright star, uh, we can see quickly the absorption lights. We save this spectrum and then we open it with this tool, spectral classification, and then we are gonna compare this spectrum with a spectrum from a main sequence atlas. Okay, now it's easy to compare if I choose the difference between the two spectra, sorry, and we changed. Okay, we can see that it seems to be a stars near an A5. Also, I can use a tool to identify what kind of element corresponds to each one of the absorption lines. Here I can choose spectral line table and I begin to choose all of the absorption lines and can deduce what elements um, have this has this star. And finally, the other exercise I use with my students is the Hubble redshift distance relation. Here, it's preferable to choose a 1 meter telescope or a 4.0 meter telescope. Let's request for a 1.0. Okay, now I have 5 data from all of them. Okay, control panel again, and slew to one of the galaxies. Of course, students have to take data from all 13 galaxies and make a graph, and from this graph deduce the Hubble law. With Hubble law, they can also deduce the age of the universe. So also a very interesting exercise uh, which use spectroscopy. So now I can access the spectrometer and take the spectrum. So at this point we have the spectrum of the galaxy with three or at least three absorption lines. If we compare their wavelengths with the rest wavelengths of the same elements, chemical elements, we can deduce the speed the galaxy is moving away from us. So also observing the apparent magnitude, we can, if we suppose this galaxy have an absolute magnitude, we can deduce their distance and then we can, with all galaxies, we can make the graph of speed versus distance, and with this graph we can deduce the Hubble law. Also, with Hubble law, we can deduce the age of the universe. So it's another very interesting exercise with which we practice spectroscopy. Thank you. Now I'm ready for your questions.
Yeah, thank you, Mauricio, for introducing the audience to the CLEA software. It's been 15 years and it's still doing great. It's still at use. I'm sure you are successfully doing it with your students and with your audience. That's great. Yes, Carl, you have.
Mauricio, that was good. Now, is CLEA, you use a downloaded version? Is it still available to people?
Yes, it is, Carl. It's free and it's very good. I enjoy it very much.
That's great.
The manual too. The two manuals are free to download.
It's
Also, you can Google through the internet and find other manuals.
Great, very nice.
Any questions? Any other questions?
I like the dome, the noise it makes, and something fell down, and it seems to be as realistic as possible.
I have some comments here. Mauricio, is this tool available for others? The sound effect of the telescope opening is wonderful. This is from Sugumar here. And another comment from Vanessa, it says that the spectra to compare can be other spectra than know in that database of the software or not?
I don't know, honestly. I used to use the spectra that the software came with.
And you said that the tool is still available for others, so they could download it and use it, right?
Yes, it
is. The question of Sugumar, yeah. Can you put the link actually of this maybe in the chat so people?
Sure. Just a second. Okay, this is the link.
Yes, thank you. So how long does it take actually to make one of the workshop? You said that there are 16 workshops that you developed using the software.
The software came with near 10 laboratory exercises, and I use until now 3 of them. But I want to use all of them. They are very good, and they are very old. That's what I admire, because I used them from 15 years ago. I discovered the CLEA project, and that's why I wanted to make a special a presentation of this CLEA software, because I'm very grateful with all the team that designed CLEA software.
Mm-hmm. Any other questions from the colleagues or the participants? We still have time, so if you have any ideas to suggest or any comments, please go ahead. If not, well, thank you, Mauricio, and then
thank you, Hassan.
We'll have plenty of time for Carl.